Welcome back, focused learners, to another explainer. We've got a truly fascinating journey ahead of us today. We're going to dive right into the transition from the raw, completely unfiltered chaos of everyday information that literally surrounds us all the time, straight to the incredible power and clarity of structured spreadsheets. Seriously, if you've ever stared at a massive wall of numbers and felt totally overwhelmed, or if you've just kind of wondered how data analysts actually make sense of the world, well, you are in the exact right place. We are going to break down the very anatomy of data itself. Let's get into it. Okay, here's our quick roadmap for today. We'll be hitting 5 key areas. First, data is everywhere. Second, why collect data. Third, the chaos of raw data. Fourth, anatomy of a data table. And finally, number 5, the rules of variables. All right, kicking things off with section 1, data is everywhere. What exactly is data today? Without us even realizing it, our daily actions generate this absolutely enormous, continuous trail of information. I want you to just pause for a second and really consider this fundamental question. What is data? It's a word we hear constantly, right? But at its core, data is simply facts and figures collected together. Whether you're just keeping a daily household account, like writing down 200 for groceries on Tuesday, 100 for petrol on Wednesday, or simply clicking your mouse on a website, you are actively generating data. You really don't need to be a formal statistician to be a part of this data ecosystem. We're all creating it, literally every single minute of the day. To put that into perspective, if we look back, say, 50 years ago, data was largely just static numbers. It was categorical. It lived in these rigid, dusty ledgers. But today, wow, the definition has expanded drastically. We're talking about social media analytics, multimedia analytics, text analytics, the whole shebang. Every single time someone leaves a comment on a product portal or hits a thumbs up on a new song, that textual multimedia response, that is data. It's a massive, incredibly varied flow just waiting to be processed into meaningful information. Moving right along to section 2, why collect data? Understanding the characteristics of groups. So we collect all of this information for a very specific reason, to understand the characteristics of diverse groups. And we are absolutely not restricted to just studying people. I mean, sure, we look at students and their marks, or patients and their body temperatures. But we also study objects, like cars, tracking the number of doors, whether it takes diesel or electric, its overall mileage. We study states, looking at populations and literacy rates. We study places, like, say, analyzing the monthly temperature trends in Chennai. We even study media, like tracking the likes and dislikes on a brand new song. We gather all of this so we can answer specific, targeted questions about these unique characteristics. Now, this brings us to a really foundational mindset shift when working with information. There's this great quote: "You do not want the data to say anything. You, in fact, use data to extract information." This is incredibly powerful. As someone working with data, your job isn't to walk into a spreadsheet and force a specific narrative. You aren't trying to make the numbers magically agree with your own bias. Data is a fact. You use it to impartially and objectively extract what is already there. It's totally objective. That brings us to section 3, the chaos of raw data, the problem with unstructured information. Okay, here is the core conflict of our entire explainer. Raw data on its own is practically useless. Just imagine a retail worker handing you this exact chaotic checkout list at the end of a long shift. Let's just read through it. Customer 1 bought Maggie, Kit Kat, Pepsi, and Colgate. Customer 2 bought Maggie, Coke, and a toothbrush. Customer 3 bought tea, water, and cookies. I mean, you can physically feel the disorganization just looking at it, right? Technically, yes, this is data, but it's entirely unstructured. It's a mess. So ask yourself, can we make any true meaning out of this unorganized, scattered information? What if this retail worker handed you a notebook with 50 customers listed exactly like this? Or what about 500? You'd be totally lost. You wouldn't easily know how much Maggie was sold overall, or what percentage of people bought a toothbrush. This really highlights the compelling, frankly desperate need to organize this unstructured mess into something we can actually analyze. Let's fix that in section 4, anatomy of a data table, bringing order to the chaos. Instantly, the information becomes readable once we use a spreadsheet, like Google Sheets, to give it a formal structure. Just look at the difference here. We have Anjali and Ramu clearly defined, with their gender, their educational board, and their marks precisely lined up. The cognitive load just vanishes. It's like a giant puzzle finally snapping together. But to build this effectively, we really have to understand its microscopic anatomy.
Let's break down the parts, starting with variables. A variable is a characteristic or attribute that varies across all units. In a data table, these are always represented by the vertical columns. Now, the absolutely crucial keyword here is that it must vary. Things like marks obtained or gender, these naturally change depending on exactly who we're looking at. Now, contrast that with a case, which is sometimes called an observation. A case is the specific individual item or event that we're actively observing. Cases take up an entire horizontal row. So Anjali is a case. Ramu is a case. For each individual case, we record the specific value of every single variable across that row.
To truly understand why variables must actually vary, check this out. Notice how the column for fees paid is a constant 30,000 rupees for Anjali, Bernard, and Callum. Because this number absolutely does not vary across our cases, there's literally nothing to analyze here statistically. Everybody pays the exact same amount. But meanwhile, look at the marks column. It changes, right? 75, 83, 92. That variability gives us something to actually study, proving exactly why true fluctuating variables are the very heartbeat of data analysis. All right, final stretch, section 5, the rules of variables, keeping our spreadsheets accurate and consistent. Let's build on this with some strict rules we absolutely must follow, starting with a golden rule illustrated beautifully by Cricket. Imagine you're tracking wickets taken. If the player Gautam Gambhir bowled 13 overs but didn't get a single wicket, you record a 0. He participated and the end result was 0. Fair enough? But what about Dinesh Karthik, a wicketkeeper who didn't bowl a single over in the match? Well, you cannot put a 0 there. A 0 implies he tried and failed. Instead, you'd put a dash or write not available. The characteristic simply wasn't measured for that case. Trust me, confusing a true 0 with a not available will completely skew your data. Let's walk through a quick hospital scenario to hammer home another critical rule, the absolute necessity of consistent units. Imagine the 7:30 a.m. shift nurse records incoming patient heights in centimeters, say 180 centimeters. Okay, cool. Then shift change happens. The 9 a.m. nurse prefers feet in inches, so they just start writing 6 in the exact same column. Suddenly, any statistical software looking at that column thinks the new patient is literally 6 centimeters tall. Inconsistent units will completely corrupt the entire variable's integrity. You simply must pick one unit and stick to it universally. You know, that flows right into our final rule. Even if 17 Feb 2003 and 19 years old technically convey the same ultimate reality about someone's age, mixing those formats in a single column is entirely incorrect. You're basically violating the rule that each variable must use the exact same type of value for each case. If your column is date of birth, everyone needs a date format. If your column is age, everyone needs a numerical integer. Consistency is absolutely everything when you're trying to bring order to chaos. So as we wrap up this explainer, I want to leave you with a bit of a challenge. If you look closely at your own daily life right now, your digital footprint, your household habits, the media you constantly consume, what unstructured data are you generating right this second? And more importantly, armed with this brand new understanding of structural anatomy, how would you organize that messy chaos into precise rows of cases and consistent columns of variables? Think about it, because data is everywhere, and now you've got the blueprint to actually understand it. Keep learning, and I'll catch you guys in the next explainer.